Imagine waking up tomorrow to headlines that sound impossible. Europe plunged into record cold. Sea levels suddenly rising along America's east coast. Monsoon patterns collapsing. Global food production under threat. And the cause isn't a volcano, a meteor, or a nuclear war. It's an invisible river in the Atlantic Ocean. A current so massive that it moves nearly 20 million cubic meters of water every second, almost 100 times the flow of every river on Earth combined. It's called the Gulf Stream. And if it ever stopped, Earth's climate would be transformed in ways few people imagine. The Gulf Stream is part of something much bigger called the Atlantic Meridional Overturning Circulation, or AMOC. Think of it as Earth's central heating system. Warm tropical water travels north across the Atlantic, carrying enormous amounts of heat toward Europe. As the water reaches colder regions near Greenland, it cools, becomes denser, sinks deep into the ocean, and flows back south beneath the surface. This endless conveyor belt has been running for thousands of years. Without it, northern Europe would be far colder. Cities like London, Dublin, and Oslo enjoy much milder winters than places at similar latitudes because of this ocean current. But this incredible system has one weakness: fresh water. As global temperatures rise, Greenland's ice sheet is melting faster than ever. That meltwater pours into the North Atlantic, diluting the salty ocean. Salter water is heavier. Fresh water is lighter. If enough fresh water enters the system, the Northern Ocean may no longer become dense enough to sink. And if enough sinking is disrupted, the entire circulation begins to weaken. This isn't just science fiction. Scientists know that the AMOC is slowed by roughly 15% since the mid-20th century, making it one of the weakest periods in at least 1,000 years according to several climate studies. No one knows exactly when or even if it could reach a tipping point. Some researchers believe it could remain weakened for centuries. Others warn that continued warming increases the risk of a much more dramatic collapse. The uncertainty isn't whether the system is changing. It's how far it could go. So, what would happen if the Gulf Stream stopped? Ironically, even though the planet is warming overall, parts of Europe could become much colder. Winters would become harsher. Growing seasons would shrink. Snowfall could increase in some regions. Meanwhile, the rest of the world wouldn't simply stay the same. Global weather patterns are interconnected. The tropical rain belts could shift southward. African and Asian monsoons that billions depend on for agriculture could weaken. Entire farming regions might struggle with unpredictable rainfall. Some places would face severe drought. Others could experience relentless flooding. The effects wouldn't be evenly distributed, but everyone would feel them. The oceans themselves would also change. Along the eastern coast of North America, sea levels could rise faster than the global average. Normally, the Gulf Stream helps pull water away from the coastline. If that flow weakens, water begins piling up against the shore. Cities like Miami, New York, Boston, and Norfolk could face higher flooding risks, even without stronger storms. At the same time, marine ecosystems would be thrown into chaos. The Gulf Stream carries not only heat but also nutrients and oxygen throughout the Atlantic. Fish migrate along these currents. Plankton, the tiny organisms forming the base of the ocean food web, depend on them. Disrupt the current, and entire food chains could be reshaped. Commercial fisheries worth billions of dollars might decline. Species would migrate into unfamiliar waters. Some ecosystems might never recover. This wouldn't happen overnight. Movies often show ocean currents stopping in a matter of days, triggering instant ice ages. Reality is slower. The Gulf Stream wouldn't simply slam on the brakes. If a major collapse occurred, it would likely unfold over decades rather than hours. But that's exactly what makes it dangerous. Slow changes are easy to ignore. Year after year, the climate shifts just enough to become the new normal. Until one day, people look back and realize the world they grew up in no longer exists. Perhaps the most unsettling part is that this has happened before. During Earth's distant past, massive floods of fresh water entered the North Atlantic as giant ice sheets melted. Evidence preserved in ocean sediments suggests the AMOC weakened dramatically, triggering abrupt climate changes across large parts of the Northern Hemisphere. Nature has already demonstrated that this system can fail. The question is whether human-driven warming could push it toward another tipping point. Scientists continue monitoring the Atlantic with satellites, deep-sea sensors, research ships, and underwater moorings. Every new measurement helps improve our understanding of one of Earth's most important climate engines. There is still considerable uncertainty about exactly how the AMC will evolve during this century. Some climate models predict substantial weakening. Others project that a complete collapse remains unlikely before 2100. What they all agree on is this: the system is changing, and understanding those changes is becoming increasingly important. The Gulf Stream is invisible from the shore. You can't hear it. You can't see it. Yet every second, it silently transports enough heat to shape continents, influence storms, feed oceans, and stabilize climates across the planet. It's one of the greatest hidden forces on Earth. A reminder that sometimes, the systems we rarely think about are the ones holding our world together. And if that invisible river ever truly stops,